Some of you may have noticed, if you're here at the beginning of streams or if you watch them in the archive, that I've got a little challenge here. If you've got some hardware, you can send it and we can reverse it. And I try to take that pretty seriously, so we've actually been looking at some of those devices recently on the stream. Alright, so this one comes from Jason Olefsky. I think this comes from New York. I think I'm just gonna have to open it with a different tool each time. Oh, what do we got in here? We got foam. Bubbles. Paper. So this comes from Jason, and here you are, a FLIR 1. Good luck. I hope you can get something useful out of it. So yeah, this came with an explanation earlier. Jason offered to send me this FLIR 1 that was, I think it was either discontinued or didn't work on any modern iPhones or some combination of those. And so it might actually be a useful kind of teardown subject to just use it as a thermal camera sensor for perhaps FLIR purposes. Because yeah, I have a couple of thermal cameras here. I've got a FLIR TG165, which I still use as just a pretty general purpose shop thermal camera. I've also got a donated FLIR 1 that Kate sent in a while ago. And that one's been like potentially on the chopping block for similar activities, but I still can get that one to work with my phone most of the time. So it's actually been a useful supplement for the TG165. It's not quite as reliable, but when I do get it to work, it actually produces pretty nice images. So I wonder if this is a similar vintage, actually. Oh, actually this one might be very similar to the one I have from Kate. They might be having similar problems even. Yeah, I mean, we should definitely take apart and repurpose at least one of these now. Potentially both of them, but yeah, that's great. This is the part number is 435000101. So is this the first FLIR one? This has a camera, a visible camera and an IR camera right next to each other. And the iPhone software actually does a decent job of combining those images. And as you can see, it's got its own battery power too. It looks like they've already tried to open it from this corner, and that might be how you get in. It's a pretty thin little piece up there. Cool. Well, thanks so much. We'll have to dig into this in a future stream and take this apart and figure out how we can best repurpose it. So this is from Ben Henk. Forget how you say his last name, sorry. But this is from Ben in Santa Cruz. Sweet. Looks like that's our thing. Wow, that's great. Alright, so we've got an ESP8266. Looks like a few extra GPIOs and a serial port. And these go to the LEDs. And I think this is designed for APA 102 or similar SPI LEDs. But let's take a look at the webpage. The Electromage Pixel Blaze, which is a great name. Yeah, so it's got a little built-in web server where you can edit patterns. Here's the wiring. Okay, yeah, APA 102s. Yeah, HDR color, that's nice. And built-in level shifting. I don't have a long strip of these LEDs handy, but I have this little offcut that we could wire up. Most of my stash right now is still WS2812s. Oh, I was gonna say I just used in the FLIR, but we could like connect one of the FLIR rings to this because they're already wired. What do you know? Ah, these silicone wires are really nice. Alright. Yeah, we got the right kind of LEDs. Cool. Okay, so you can power over USB or from the screw terminal. That's nice. Okay, so there's like a setup network. Okay. We have some pulsing now. That's nice. That's a fairly pleasant way of not being configured. Okay, yeah, setup mode means pulsing yellow-orange. So yeah, we should be in setup mode. We should see Wi-Fi right now. Great. Pixel Blaze. Oh, 192.168.4.1. Alright. Configure Wi-Fi, no scan. Cool, I'm going to give it the SSID and password to my real non-guest network, so I'm going to blank this for a sec. We'll have some cat. When you enter the Wi-Fi username and password in the form, it then redirects you to a page with the username and password both in the page URL. So this is what we've got. I blanked out the URL because otherwise it would have had my credentials in it. Thanks. Oh, so they're just like nmap it. Oh, here it is. Great. Oh, now it's just running. That's convenient. So we can just click one of these and edit it. Yeah, I mean, like, if this could do a multicast DNS broadcast so that you could just go to pixelblaze.local, that would be pretty cool. There's also the thing that like Raspberry Pi does, where there's like a desktop app you can get that'll help you find it. But yeah, having to go on a Safari on your local network to locate it is a little bit annoying. But that said, everything else about this has been pretty awesome so far. So, Saved Patterns tab. Is this like a real-time view of what's going on the... I think so. It says over here, frame rate, instructions per second. Let's get this compact enough that you can actually see it on the screen. This is great. So we've got some kind of wide color bands that go back and forth, it looks like. Time. So what does that time do? Oh, nice. So these create oscillators. Yeah, this is really nice. What is I? Current pixel. Oh, so this is like the size of the little blips that we've got. Is L the length of the whole thing? Yeah. Robert is asking, is it a custom DSL? Which by that I assume that they mean a domain-specific language, and it looks like the answer is yes. It looks like it's just a simple expression language that compiles into some kind of virtual machine. Yeah, the fixed point math is pretty nice. I appreciate that. And HSV just generates the color. What is the actual color format here? Oh, this sets the current pixel. Okay, so this is like an output function that you're calling. Maybe it would be more fun to start with something new. And what if we just wanted this to be a gradient? This would be like I over L. If we wanted to base this on a sine wave. Do we have pi? We do. We even have 2 pi. Okay, so there's one sine wave, and you'll notice the second half is all black because it's been saturated from negative to 0. So we're only seeing the top half of the sine wave. It's been rectified. And then what we were doing before was just taking this to the 4th power, and we're seeing the other half of the sine wave. So this basic timer loops between 0 and 1, whereas this just kind of includes multiplication, which might be nice if we're doing something circular. Oh, interesting. So is this one up here running live in JavaScript, and then this one's running in a simulator? Yeah, that top one updates first. Neat. I'm wondering if you can do multiple HSV conversions and then combine the results. Yeah, so you could do something like this where you color it in RGB space and then just sum these together to have multiple blips. Yeah, this is fun. Yeah, a lot of nice built-in functions, and I can see how you could build up a lot of interesting functionality just by using the basic primitives here. So yeah, I think that's probably a good stopping point for this, but this is super fun. I'm gonna have to play with this more. Thanks so much for sending it. So this is a hardware donation from Axel Thielman. The box is already slightly starting to open itself. Oh, sorry, this is not hardware, this is a book. That's right. That's right. This is a rare book that they found at a local library that was cleaning up shop and thought about me. Ah, yes. Ah, the Multics system. Oh, that's great, from the MIT Press. Ah, man, yes, I'm an operating systems aficionado. The Multics system, an examination of its structure. So I appreciate this. I've never really dug into Multics at all, but oh yeah, from Hamburg. Oh man, the GE645 paging hardware. All sorts of linked lists. I wonder if this had cache. So we're talking about memory segmentation, basically just going through the really basics of what you would need to start using a computer for multiple users. You know, privilege levels and memory segmentation. These really nice diagrams too. Yeah, where do we get to later on? Oh, linking? Segment binding? Oh yeah, relative addressing? Entry sequences? Yeah, like this is like a stack of all the computer architecture bits. A lot of access control. Ooh, ring crossings. Sort of system calls, basically. I assume that's what they mean by ring crossings here. It's like how the system call arguments are encoded in the stack. I'll have to go through this in some more detail. Wow, thank you. Oh, is that a library card in the back? Oh, yeah. That's great. Yeah, well, thank you so much, Axel. We'll have to dig deeper into this and share some gems that I find with all of you. Oh no, I'm like, is this gonna open and out is gonna pour like some mixture of like flammable chemicals, personally identifying information, and packing peanuts, and we're on a good start here. I think it's fine. More lab isopropanol. I don't check this every day, so I don't know exactly when this came in, but I think it was sometime last week. Yeah, this comes from Eric Cook, and it's delivered to this lovely P.O. box in Emeryville. And so, yeah, thanks so much. Let's see what's going on in here. So Eric says, hi, I like watching your stuff. Much of it goes right over my head, but I can understand enough of it to be impressed. Pretty sure this works. Thought you might find a use for it or some of the components. Keep on hacking. Well, thank you. Oh, it's another camera. Axis M30. I've looked at these online so far, and they're usually like a bit out of my price range, so I've not actually seen these up close. Well, that's pretty cool. Thank you so much, Eric. Let's dig in. They're helpful enough to give me a template so I can mount it on the wall, which, if it isn't horribly insecure, maybe I would want to do, perhaps. It is useful to have cameras here. Like, I've got I've got an overhead camera that takes a sec for the video streaming to start, but it is eventually kind of useful. Hello! Well, let's see what it says on the outside before we dig into this quite yet, because I'm curious what this is actually advertised as. Is this power over Ethernet? Looks like it. It is connected to the www, the one and only. Neat. Yeah, this feels expensive. Feels like it's made of a lot of metal. And that goes right to a shielded RJ45. That looks very nice. In case you want the cord to come out sideways instead of going through the wall. Include a wrench. Software CD. Well, these are already loose. Wow, it's like a little space station. What might be a reset button right there? And an SD card slot or a SIM slot? Probably an SD slot. And this might be a focus. That's gotta be focus. It's even graduated here. And then there's a weather-proofing gasket here. This section's loose-ish. Oh, and this section is slightly differently loose. Great. So that covers up the little cable entry gland. And that whole thing also covers up this additional screw hole. Great. So the camera is actually attached to the lens assembly by a little wire. It's not a flat flex, it's actually a ribbon made up of, looks like 32 gauge Kynar wire or something along those lines, or Teflon wire. That is very delicate and expensive looking. Yeah, I don't know off the top of my head how to get that out non-destructively. And I might just try leaving it in. So SD card, more screws, which we'll take out in a sec. Got some RAM. This is going to be some kind of system on chip, I assume. Some DC converter stuff. That's the coil for the DC, or for the power over Ethernet, and then the coil for the data. And the Ethernet is actually just punched down directly onto the board. I've never seen that before. These are like telecom punch downs. Also thinking about debug interfaces, we've got a couple of good ones on this side. There's a 4-wire port, which is quite likely serial, and then 6-wire, which might be JTAG. Oh, there's one here that's even labeled debug, this unpopulated 6-pin. Oh, maybe I was just being too gentle. I think that worked. Oh yeah, there's a thermal pad. Ooh, is that a branded chip? That's a hell of a place to put the battery. Okay, so we have more RAM. That is a custom chip. The label is just Access Communications ARTREC 4, ARTREC-4. I've got an opto-isolated section for the power supply. This is a Broadcom chip over here. It's near the camera. Well, thanks so much for the camera, Eric. I hope we can dig into this and do something interesting. It's already proving to be by far the best made security camera I've taken apart. Yeah, by the way, this is all from Tuco. The scratches aren't too bad. The ones that are more like punctures are the ones that are still hurting a little bit. I mean, I know cat bites can be pretty nasty. There was one time that Tuco was really excited about some food, ended up getting my thumb in there, and then this is an earlier one. This was from a few weeks ago. Tuco and I had a fire drill to attend to, and so I was trying to get him outside, and he was not having that. This one comes from Vincent Ebeacham, I think. Oh, okay, Vincent Ebeacham. That's Vincent in chat. Great. Connecting the dots. Thanks so much. What is this? Are these really nice surface mount probes? These look like they're for surface mount parts for doing like manual pick and place with tweezers. That's great. And then these are really tiny grabbers. Oh, and they come with leads. Nice. I hope these aren't aluminum. Ah, Vince says it's a case for these probes. Delightful. Alright, well, unfortunately I can't see the warnings, but it probably is like, be gentle with these. Don't hurt yourself. Don't break them. ESD, that kind of stuff. So the short end goes on this plug, the long end goes on your IC. There we go. So by pulling that toward the wire, it sticks out the probe. That is beautiful. Yeah, and see how they cross each other and then form this little hole that the wire is trapped in? That's great. Ah, well, thank you so much. These will be great next time I have to get some signals off of some SOICs or probably TQFPs. Oh, I think they get individual spots. Wow, that's great. Well, that's enough probes to, to do pretty much anything you want with serial flash, for one. Yeah, that looks pretty big compared to the TQFP. That's not gonna do without shorting its neighbor, probably. Yeah, so that's a really secure connection that's not going to short to any of its neighbors. That's great. You could also attach to a button if you really needed to pilfer someone's reset signal, maybe. Or a crystal. Really need to know about that 32 kilohertz. Got a bag, got paper, and a box. Ah, yes. Okay, I think we had talked about this. I think they offered to send me this Cypress super speed kit. Ah, yes. This looks super fun. I don't entirely know what I want to do with this yet, but I don't know, like I've always enjoyed using USB as a high-speed pipe to just shove data into the computer and do something fun with it. Yeah, I would love to play with the FX3. And this FX series is basically Cypress's kind of main USB system-on-chip line. The most infamous one, at least the one that I'm most familiar with, is the FX2. It's still actually really popular. Like, a lot of the Cellier logic analyzers and similar devices use them. It's basically just a pretty nice little high-speed, so in this case 480 megabits per second for the FX2, a high-speed USB serial engine, plus basically a programmable hardware state machine that you can use for interfacing with various peripherals, little 8051 8-bit microcontroller core. So that was the FX2, and it was massively popular. And I did a few things with it, used it for some FPGA-based projects. And then FX3, so you might imagine that with all the extra bandwidth we're dealing with, you'd need a bit more processing. And so, as you can see, we have an ARM9 microcontroller with a 0.5 megabyte of SRAM, which is pretty formidable here. We've seen these chips. I think the last time we saw one of these on stream was inside the Tobii eye tracking camera we took apart. I think they were using one of these as a camera controller. SRAM enable. Demonstrating the USB transfer rate. Always something you gotta do on one of these boards, right? But that is actually an important thing for the silicon vendor to give out, because actually getting the device's maximum throughput requires some fairly careful software design. So I'm sure they end up with a lot of people complaining that the hardware doesn't give them all the throughput they want, and they just haven't written their software in a way that's capable of that level of efficiency. The biggest thing is usually writing software that can handle multiple overlapping transfers at once. So you can be requesting that the OS do one transfer while another one is already pending. Wow. So what is that big thing on the back? Is that... So on the top side, we've got the FX3 in the middle, power, USB serial debugger. That's interesting. I don't see a mention as to what's on the other side. What is this chip? CY7C1062. So we have a 2.4 gigahertz antenna module. This is the NRF24L01, which is a really nice chip. Oh yeah, these look familiar. Yeah, these little radio modules are great. Cool, this is the Raspberry Pi I/O expansion board. We've got a bunch of push connectors on the top. I'm curious what this chip is. Okay, maybe this, when I read I/O expander, I usually assume that's like a thing that hangs off the SPI bus and gives you more GPIO, but I think this might be more like a wiring breakout board. Because this plugs into the Raspberry Pi header, it gives you a pass-through header, and I guess the way this works is you can just connect them straight across if you like, or you could use patch cords to wire them up in some other way. Oh, that's handy. Well, this is great. Well, thanks so much for sending all the goodies, and we've got at least a few things here that could be entire videos all onto their own, so Well, let me know if you have anything that you'd love to see me do with any of this stuff. I will certainly be thinking about what we could do that would be as interesting and as informative as we can muster, but if you have ideas or things that you would love to see, I would love to hear about them. So, as always, you can ping me on Twitter or write me an email, and I would love to hear from you.